NFPA 70E does not specify a frequency for testing gloves, blankets, or other electrical protective equipment at intervals less than 3 years. A statement about 6-month testing requirements is likely based on a misinterpretation of Section 130.7c12 in NFPA 70E. That section states that rubber insulating gloves shall be visually inspected prior to each use. If any damage is noted, the gloves shall be discarded. This section requires visual inspection of rubber insulating gloves before each use, but it does not specify a testing frequency. In the absence of specific guidance in NFPA 70E, refer to the manufacturer's instructions for the proper testing frequency of specific equipment. Additionally, some local or regional regulations may have more specific requirements for the testing frequency of electrical protective equipment. It is essential to check with local authorities to ensure compliance with all applicable regulations. Regarding electrical safety, it is imperative to follow established safety standards and guidelines to mitigate risks associated with electrical hazards. These standards provide a framework for safe work practices, equipment maintenance, and personnel training, ensuring the well-being of individuals working with or near electrical systems. The National Fire Protection Association 70E, often referred to as NFPA 70E, is a consensus standard developed to provide guidance on electrical safety in the workplace. Its primary objective is to protect employees from electrical hazards by establishing requirements for safe work practices, hazard assessment, and the use of personal protective equipment. NFPA 70E outlines the responsibilities of both employers and employees in maintaining a safe electrical work environment. Employers are responsible for conducting hazard assessments to identify potential electrical hazards in the workplace. This assessment should include evaluating the severity of potential electrical shocks, arc flashes, and arc blasts. Based on the hazard assessment, employers must implement appropriate safety measures to mitigate the identified risks. These measures may include energizing electrical equipment before commencing work, using lockout/tagout procedures to prevent accidental energization, and providing employees with appropriate personal protective equipment. Employees also have a crucial role to play in maintaining electrical safety. They are responsible for following established safety procedures, using personal protective equipment as required, and reporting any electrical hazards they encounter in the workplace. Employees should also participate in training programs to enhance their knowledge and skills in electrical safety practices. Safe work practices are essential for preventing electrical accidents and injuries. These practices include maintaining a safe distance from energized electrical equipment, using insulated tools and equipment, and avoiding working in wet or damp conditions. Lockout/tagout procedures are critical for preventing accidental energization of electrical equipment during maintenance or repair work. These procedures involve isolating the electrical circuit, applying locks and tags to prevent unauthorized operation, and verifying that the equipment is energized before commencing work. Personal protective equipment, or PPE, is the last line of defense against electrical hazards. PPE includes items such as arc-rated clothing, insulated gloves, face shields, and safety glasses. The type of PPE required depends on the severity of the potential electrical hazards. Regular inspection and maintenance of electrical equipment are essential for ensuring its safe operation. This includes inspecting wiring, connections, and insulation for signs of damage or deterioration. Any damaged or defective equipment should be repaired or replaced immediately. Training is a critical component of electrical safety. Employees who work with or near electrical systems should receive comprehensive training on electrical hazards, safe work practices, and the proper use of personal protective equipment. Training should be conducted regularly to reinforce safety procedures and keep employees up to date on the latest safety standards. In addition to NFPA 70E, other relevant standards and regulations address electrical safety. These include the National Electrical Code, or NEC, which provides guidelines for the safe installation of electrical wiring and equipment. The Occupational Safety and Health Administration, or OSHA, also has regulations pertaining to electrical safety in the workplace. Compliance with these standards and regulations is essential for ensuring a safe electrical work environment and preventing electrical accidents and injuries. Electrical safety is a critical aspect of workplace safety that requires a comprehensive approach involving hazard assessment, safe work practices, personal protective equipment, and training. By following established safety standards and guidelines, employers and employees can work together to create a safe electrical work environment and protect themselves from electrical hazards. It is important to remember that electricity can be dangerous, and even a small shock can have serious consequences. Always take the necessary precautions and follow established safety procedures when working with or near electrical systems. Arc flash is a dangerous phenomenon that can occur when electrical equipment is subjected to a short circuit or other fault condition. An arc flash is a release of thermal energy caused by an electrical arc. It can cause serious burns, eye injuries, and even death. Arc flash hazards are present in many workplaces, including power plants, industrial facilities, and commercial buildings. Electrical workers are at the highest risk of arc flash injuries, but anyone who works near electrical equipment can be exposed to this hazard. To protect workers from arc flash hazards, employers must conduct hazard assessments, implement safety measures, and provide appropriate personal protective equipment. Hazard assessments involve identifying potential arc flash hazards and evaluating the severity of the potential injuries. Safety measures may include energizing electrical equipment before commencing work, using lockout/tagout procedures, and installing arc flash barriers. Personal protective equipment, or PPE, is the last line of defense against arc flash hazards. PPE includes items such as arc-rated clothing, face shields, and gloves. The type of PPE required depends on the severity of the potential arc flash hazard. Arc-rated clothing is designed to protect workers from the thermal energy of an arc flash. This clothing is made from special fabrics that are resistant to heat and flames. Arc-rated clothing is available in a variety of styles, including shirts, pants, jackets, and coveralls. Face shields are used to protect the face and eyes from arc flash hazards. These shields are made from impact-resistant materials and are designed to block the intense light and heat of an arc flash. Gloves are used to protect the hands from electrical shock and arc flash hazards. Insulated gloves are designed to provide protection from electrical shock, while arc-rated gloves are designed to provide protection from the thermal energy of an arc flash. In addition to PPE, employers should also provide workers with training on arc flash hazards and safety procedures. This training should cover topics such as arc flash hazard assessments, safe work practices, and the proper use of PPE. Regular training is essential for ensuring that workers are aware of the risks and are able to protect themselves from arc flash hazards. Arc flash is a serious hazard that can cause serious injuries or death. By conducting hazard assessments, implementing safety measures, and providing appropriate personal protective equipment and training, employers can protect workers from arc flash hazards and create a safer workplace. When discussing electrical safety, it is important to consider several factors, including the type of equipment being used, the voltage levels involved, and the potential hazards present. Understanding these factors is crucial for implementing appropriate safety measures and preventing accidents. Electrical equipment can be broadly classified into two categories: high-voltage equipment and low-voltage equipment. High-voltage equipment operates at voltage levels above 600 volts, while low-voltage equipment operates at voltage levels of 600 volts or less. High-voltage equipment is typically used in power generation, transmission, and distribution systems, while low-voltage equipment is commonly found in residential, commercial, and industrial settings. The voltage level of electrical equipment is a critical factor in determining the potential hazards. Higher voltage levels pose a greater risk of electrical shock and arc flash. Therefore, extra precautions must be taken when working with high-voltage equipment. Potential electrical hazards include electrical shock, arc flash, and arc blast. Electrical shock occurs when a person comes into contact with an energized electrical conductor. The severity of the shock depends on the voltage level, the amount of current flowing through the body, and the duration of the contact. Arc flash is a dangerous phenomenon that could occur when electrical equipment is subjected to a short circuit or other fault condition. An arc flash is a release of thermal energy caused by an electrical arc. It can cause serious burns, eye injuries, and even death. Arc blast is a pressure wave produced by an arc flash. It can cause serious injuries, such as lung damage, hearing loss, and traumatic brain injury. To mitigate these hazards, it is essential to implement appropriate safety measures. These measures may include energizing electrical equipment before commencing work, using lockout/tagout procedures to prevent accidental energization, and providing employees with appropriate personal protective equipment. De-energizing electrical equipment involves disconnecting the equipment from its power source and verifying that it is de-energized before commencing work. Lockout/tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair work. These procedures involve isolating the electrical circuit, applying locks and tags to prevent unauthorized operation, and verifying that the equipment is de-energized before commencing work. Personal protective equipment, or PPE, is the last line of defense against electrical hazards. PPE includes items such as arc-rated clothing, insulated gloves, face shields, and safety glasses. The type of PPE required depends on the severity of the potential electrical hazards. In addition to safety measures, it is also essential to provide employees with comprehensive training on electrical hazards and safety procedures. This training should cover topics such as electrical shock, arc flash, arc blast, safe work practices, and the proper use of PPE. Regular training is essential for ensuring that employees are aware of the risks and are able to protect themselves from electrical hazards. Electrical safety is a critical aspect of workplace safety that requires a comprehensive approach involving hazard assessment, safe work practices, personal protective equipment, and training. By following established safety standards and guidelines, employers and employees can work together to create a safe electrical work environment and protect themselves from electrical hazards. When working with medium and high voltage systems, several key safety considerations must be taken into account to prevent accidents and injuries. These considerations include proper training, the use of appropriate personal protective equipment, or PPE, and adherence to established safety procedures. Firstly, proper training is essential for all personnel who work with medium and high voltage systems. This training should cover topics such as electrical hazards, safe work practices, and the proper use of PPE. The training should also be specific to the type of equipment and systems that the personnel will be working with. Secondly, the use of appropriate personal protective equipment is crucial for protecting workers from electrical hazards. PPE for medium and high voltage work typically includes arc-rated clothing, insulated gloves, face shields, and safety glasses. The type of PPE required depends on the specific hazards present in the work environment. Thirdly, adherence to established safety procedures is essential for preventing accidents. These procedures should include lockout/tagout procedures to prevent accidental energization of equipment, grounding procedures to minimize the risk of electrical shock, and safe work practices to avoid contact with energized conductors. In addition to these key safety considerations, it is also important to conduct regular inspections of equipment and systems to identify any potential hazards. Any damaged or defective equipment should be repaired or replaced immediately. It is also important to maintain a safe work environment by keeping work areas clean and free of obstructions. By following these safety considerations, employers can create a safe work environment for personnel who work with medium and high voltage systems. This will help to prevent accidents and injuries and ensure the well-being of workers. The term medium voltage typically refers to voltage levels ranging from 600 volts to 69 kilovolts or 69,000 volts. High voltage generally refers to voltages above 69 kilovolts. These voltage levels are commonly encountered in industrial facilities, power plants, and transmission and distribution systems. Working with medium and high voltage systems requires specialized knowledge, skills, and equipment due to the increased risk of electrical shock, arc flash, and other hazards. Only qualified personnel who have received appropriate training and certification should be allowed to work on these systems. NFPA 70E provides guidance on electrical safety requirements for workplaces, including those involving medium and high voltage systems. It outlines the responsibilities of employers and employees in maintaining a safe electrical work environment. NFPA 70E also specifies requirements for hazard assessments, safe work practices, personal protective equipment, and training. Lockout/tagout procedures are essential for preventing accidental energization of equipment during maintenance or repair work. These procedures involve isolating the electrical circuit, applying locks and tags to prevent unauthorized operation, and verifying that the equipment is de-energized before commencing work. Grounding procedures are used to minimize the risk of electrical shock by providing a low-resistance path for fault current to flow back to the source. Grounding ensures that equipment and enclosures are at the same potential as the earth, reducing the likelihood of electrical shock. Arc flash hazard analysis is a critical step in assessing the potential hazards associated with medium and high voltage systems. This analysis involves calculating the incident energy of a potential arc flash and determining the appropriate level of personal protective equipment required to protect workers. Personal protective equipment, or PPE, is the last line of defense against electrical hazards. PPE for medium and high voltage work typically includes arc-rated clothing, insulated gloves, face shields, and safety glasses. The type of PPE required depends on the severity of the potential hazards. Regular inspections and maintenance of equipment and systems are essential for identifying any potential hazards and ensuring the safe operation of the equipment. Inspections should be conducted by qualified personnel and should include visual inspections, electrical testing, and mechanical testing. Proper documentation is essential for maintaining a safe electrical work environment. Documentation should include records of training, hazard assessments, inspections, maintenance, and repairs. This documentation can be used to track safety performance and identify areas for improvement. Safe work practices are essential for preventing accidents and injuries when working with medium and high voltage systems. These practices include maintaining a safe distance from energized conductors, using insulated tools and equipment, and avoiding working in wet or damp conditions. Electrical safety is a critical aspect of workplace safety that requires a comprehensive approach involving hazard assessment, safe work practices, personal protective equipment, and training. By following established safety standards and guidelines, employers and employees can work together to create a safe electrical work environment and protect themselves from electrical hazards. Rubber insulating gloves and blankets used in electrical work are crucial pieces of personal protective equipment that safeguard workers from electrical shock. To ensure their effectiveness, these items must undergo regular inspection and testing. Visual inspection is the first line of defense. Before each use, gloves and blankets should be carefully inspected for any signs of damage, such as cuts, tears, punctures, or embedded foreign objects. The surfaces should also be checked for any irregularities, such as swelling, hardening, or stickiness. Any glove or blanket that shows signs of damage should be immediately removed from service. In addition to visual inspection, rubber insulating gloves and blankets must also undergo periodic electrical testing. This testing is typically performed by a qualified testing laboratory and involves subjecting the gloves and blankets to a specified voltage to verify their insulating properties. The testing frequency is typically determined by industry standards, such as American Society for Testing and Materials, or ASTM, standards and regulatory requirements. ASTM DAN 120 specifies the standard specification for rubber insulating gloves, while ASTM D1048 specifies the standard specification for rubber insulating blankets. These standards outline the requirements for the design, construction, testing, and marking of gloves and blankets. The testing frequency for rubber insulating gloves is typically every 6 months, while the testing frequency for rubber insulating blankets is typically every 12 months. However, the testing frequency may vary depending on the specific application and the environmental conditions in which the gloves and blankets are used. For example, gloves and blankets used in harsh environments or subjected to frequent use may require more frequent testing. The electrical testing of rubber insulating gloves and blankets involves several steps. Firstly, the gloves and blankets are visually inspected to ensure that they are free from any obvious defects. Secondly, the gloves and blankets are subjected to a cleaning process to remove any dirt or contaminants that may affect the test results. Thirdly, the gloves and blankets are placed in a testing apparatus and subjected to a specified voltage. The voltage is typically applied for a period of 3 minutes, and the leakage current is measured. The leakage current must be below a specified limit for the glove or blanket to pass the test. After the electrical testing is complete, the gloves and blankets are visually inspected again to ensure that they have not been damaged during the testing process. Any glove or blanket that fails the electrical test or shows signs of damage is removed from service and discarded. Proper storage of rubber insulating gloves and blankets is essential for maintaining their integrity and extending their service life. Gloves and blankets should be stored in a clean, dry, and dark location away from direct sunlight, extreme temperatures, and chemicals. Gloves should be stored in a manner that prevents them from being folded, creased, or compressed. Blankets should be stored flat or rolled up to prevent damage. Regular inspection, testing, and proper storage are essential for ensuring the safety and effectiveness of rubber insulating gloves and blankets. By following these practices, employers can protect workers from electrical shock and create a safer work environment. Additionally, it is important to consult with the manufacturer's recommendations and local regulations for specific guidelines on inspection, testing, and storage requirements for rubber insulating gloves and blankets. These resources can provide valuable information and help ensure compliance with applicable safety standards.